Good morning. My name is Manuela Salgado, and we're going to talk about the death of supermassive stars. Okay. Okay. First of all, we're going to talk about what's a massive star, what's the end life process. After that, the stability in space. After collapsing signals, and at the end, what are the remaining objects that appear in the space after a supermassive star in its life. Okay, we're gonna start about what's a massive star. A massive star is, sorry about that. A massive star, it's what a a supermassive star is a star with initially 60 to 1,000 times more mass than our own sun. So if we see in a comparison, the sun is a really tiny type of star, and the massive star, it's millions and millions times bigger than the actual sun. It is way more brighter. It can have a wide variety of colors, like blue, like really shine, red, like yellow. It has a short span of life because they're really close to the end of their lives, meaning that there's a lot of factors that these really massive stars have to pass through to be able to end their lives. They lose their mass along a lot of times faster than their actual sun because of the size of what they because of the size and because of how happens to lose their mass. Okay, we can see. Okay, now we're going to talk about the end life process of a massive star. So massive stars, as we can see in the picture here, we start as the cloud nebula. It has a lot of elements that after a while, because of the gravity, it collapse and like make it like a dough and just infuse all the elements inside and begins a journey after a protostar. After a protostar, it's tardy phase. That means that it begins like a low medium mass star, like the sun, for example. The sun is a it would have been an example of a supermassive star, but it doesn't have the size to be a supermassive star. Supermassive stars are giant reds, supernova, and after they die, they become neutron stars or black holes. So that's the final state. This process begins a lot of years. They happen for a lot of years. Okay. Okay. So the formation of the early lives. They become in, as we could see the picture, in dense star clusters of low metallic regions, meaning that there's a lot of space dust that after a lot of gravity and movement over the years, it collapse and start creating what we know as supermassive stars. They're really far from us because of the um, gravity, and a lot of mass means a lot of gravity infused, meaning that any type of really massive stars start attracting all the objects around. So the mass gain is really high. They have a short and intense lifespan. Burns through to hydrogen and helium rapidly in a few million years. After these years are done, it start collapsing. Start collapsing. Okay, and collapse on the end of the star. It can have two. It can happen in two ways. When in the core of the star start collapsing because their elements are not stable at all, and mo- because of the movement they encounter in the space, meaning that they can lose a lot of mass over the stability of their lifespan. After all the mass is getting rid of, they can become a supernova or a black hole formation. Okay, now we're gonna talk about collapsing signals. What happened with the collapsing signals? Okay, Collapsing signals, oh, sorry. Collapsing signals can be because of radiation pressure, gravity, because of what I mentioned before, core collapses, because the temperature increases, or because of movement disturbances. Okay, so when we come about the radiation pressure and gravity, the radiation pressure dominates due because of immense energy output. Meaning, what does that means? It's when radiation is too high and the gravity tries to balance the radiation from the star moving around, like in an unusual way. Core collapses. This means that it becomes unstable, the amount of carbon and oxygen and other elements in the core, and it contributes to their instability, meaning it start contributes to their death. Okay, now we have movement disturbances. There's a lot of stellar winds and space dust that contribute a lot with the um, mass loss of the supermassive nova, supermassive star, and it allows the supermassive star to collapse. Also, the temperature increases, meaning that the temperature increases so much because of the elements in constant movement in the core of the massive star that it's not environmentally good for the supernova to continue being as it is, start dying, meaning that is it will become a supernova or a black hole. So these are some pictures of what will happen. This is a supernova, and this is another type of supernova after the death of the supermassive star. Now, remaining objects in space. What will happen after the death of the supermassive star? Okay, so the supermassive star can become three: a black hole, a peri-instability supernova, or a neutron star. Usually, as we can see all the black holes, the super-instability supernova, and neutron star. For me, it's really interesting how the black holes can be created, as you can see in the picture, the the stars that are near the black holes, either the star like visually getting larger, and it for me is really interesting that black holes can have a different type of like measure. If something is closer to the black hole, timing is different, and it's it can be like as tiny as possible or as big as possible. So black holes are really like different from what we know. So that's why it's like really interesting um to learn about them. And as we can see also in the previous, um the colors of this death of the supermassive star starts collapsing from the supernova. So the black hole is just like the addition of every element, a lot of gravitational power in the center, and in the corners is all the remainings of what the supermassive star could have done. Okay, I, here are the references. Sorry, here are the references of what I used to perform this presentation. So, thank you very much.